students, welcome to one of the last videos of the entire year. Today we're looking at functional groups, and they're going to include alcohols, ethers, aldehydes, and ketones. So make sure you are listening to the video so that you can catch all the explanations. Alright, good luck!
All right, let's get started. So we talked a little bit about hydrocarbons, branch hydrocarbons, and we talked about when we are substituting in with a halogen, which we can refer to as a halocarbon. However, we have many, many more families of other organic compounds. We're going to be looking at different functional groups, which is a group of atoms in particular position on the molecule that give that molecule a very special property. So make sure you have your reference tables out so that you can look and refer to table R. All right, the first one is an alcohol. This has a substituted hydroxyl group, OH, as their functional group. So you can see that on table R with the alcohol, this is the group that you're looking for. And you're going to notice with table R that these R's just represent a chain of carbons. So it can be any amount. The main part here that we're worried about is the OH. The naming of alcohols is very similar to the system of naming other hydrocarbons, so we're still going to define the prefix for the number of carbons, like but and pent and hex, and however, our main difference is going to be the suffix, the ending of the compound. So in this case, for an alcohol, we're going to use the suffix OL, and the position of the OH group is always going to be indicated by the lowest possible numbered carbon, just like we did when we were substituting in or finding like double and triple bonds, or when we were writing and identifying alkyl or halide groups. One thing I want to point out, you don't need to write this down, is that you can have compounds that have 2 or 3 of the hydroxyl groups, and you would see that their name is a little bit different than what we're going to be doing. You might use diol if you have 2 and triol if you have 3. Don't worry too much about this, it's just some background information in case you come across these names or similar names in the future. All right, let's get to actually naming these. And again, it's going to be very similar to how we've done it before. The main difference is the ending and focusing on the OH group. All right, so I had 4 carbons. That's why I'm using my prefix but. And then since I have this OH group, I can identify it as an alcohol. So I use the ending OL. Now, this OH group could be on any one of those carbons. So I do have to specify that I'm going to number my carbons. I, yes, could have numbered left to right, but remember, I always want to place the lowest possible number on that carbon that's attached to the group that I'm interested in. So that's why I started numbering from the right. Which means that this OH group, hydroxyl group, is attached to the first carbon. So it's as simple as that, 1-butanol. All right, here we're going to work backwards. We're going to first start off just like we normally would, develop our chain of carbons. I have 3 carbons, so prop is coming from table P in your reference tables. Now this OL is telling me that I have an alcohol, so I have an OH group that I need to place, and then I refer to the number to determine where that is. So my OH group then will be in my second carbon, and then I properly fill in the correct number of hydrogens on the rest of the carbons. All right, so it's very straightforward. It's just a matter of being able to use those reference tables and getting comfortable with writing and drawing them. One thing I want to point out that you need to know is the classification of alcohols. We have primary, secondary, and tertiary. A primary alcohol is when the hydroxyl group is at the end of the chain, whether beginning or the end. So in this case, we have 1-propanol. So that 1, having it be on that first carbon in the chain, tells us we have a primary alcohol. We can also have a secondary alcohol if that OH group is attached to a middle carbon. In this case, as you can see, it's attached to this middle one here. So we have 2-propanol, which is a secondary alcohol. And then finally, a tertiary alcohol is when it's actually in an intersection of carbons. So this middle carbon that the OH is attached to, as you can see, has 3 other carbons, so it's at an intersection of their bonds. And that means that we have a tertiary alcohol. So just some different things to keep an eye on and know those vocabulary words. All right, moving on to ethers. This is made from basically dehydrating an alcohol, and it has a general formula of ROR, the main part again being this oxygen that's going to be in the middle of a carbon chain. And again, those R groups are just chains of carbon of various lengths. All right, an ether is going to basically name the alkyl groups on each side of the oxygen, and then we're going to alphabetize them. If we have more than one of the same, then we're going to use di for 2 or tri for 3. Tri you wouldn't even have to worry about because you'd only have up to 2 groups. So you actually cross this part out in your note packet. You'd only use di if you had 2 of the groups on both sides, and you'll see why in just a second. And then at the very end, we actually end very simply with the term ether. All right, so let's look at this. Here we would identify that we have an ether because we have this oxygen by itself in the middle of a carbon chain. So that gives me the ending of ether. And then I'm going to look at each of the alkyl groups on each side of the oxygen. So on my left-hand side, I have an ethyl group. And on the right-hand side, I also have an ethyl group. So that's my second part. So again, I just wrote the 2 parts of the alkyl groups on each side of the oxygen. This would also be termed diethyl ether because I have 2 of the same groups here. All right, working backwards, I'm starting with an ether, so that means I'm going to start with my oxygen in the center. I'm then going to use my 2 alkyl groups to determine what's on each side of that oxygen. So methyl, 1 carbon with 3 hydrogens. And then ethyl, and again, where I'm getting the number of carbons is with those prefixes again. So ethyl is 2 carbons with the correct number of hydrogens. So it's as simple as that. So you have methyl, ethyl, ether. So again, a methyl group with your oxygen in the middle, then attached to the ethyl group. All right, so we're moving right along. So we've already done alcohols and ethers. Now we're looking at aldehydes. This is a little bit different because we're working with a carbonyl group, which has a carbon-oxygen double bond. And you can see by this little picture over here what that's going to look like. Aldehydes is very specific because this group ends up at the end of a chain. Okay, if it's in the middle of a chain, we're going to see that's for a ketone. So an aldehyde is specifically when this is at the end of the chain. So it's on that first or primary carbon. Naming of aldehydes, we're going to write the name of the carbon chain and then add the parent suffix of Al, which if you look at table R, you should see the example over here that I originally cut off, and you'll be able to see that Al written in the example. Again, this OH is in the end carbon, so it should always be the oxygen double bond along with a separate hydrogen to complete the 4 bonds of carbon. So here we have ethanol, and we're going to start with our 2 carbons. Then I'm going to, because of the Al, I'm going to show that I have a double bonded oxygen. I'll fill in that hydrogen correctly. So again, this is at the end of the chain, which is correct for an aldehyde, and then fill in the rest of the hydrogens. All right, moving on to our second example. Again, I know this is an aldehyde because this double bonded oxygen is at the end of the chain. This could have also been reversed, and this could be considered the end of the chain, so either side, as long as it's at the very end. I have 5 carbons, and then again I'm using the Al because I have an aldehyde, and that's it. There's no number needed because aldehydes are always on that primary carbon. All right, and then our very last one, ketones. This also has a carbonyl group, but this is specifically in the middle of the chain. So you can see here that we don't have any hydrogens attached to that carbon because it has to be in the middle. So there has to be different chains of carbon attached to on either side. We're going to have to indicate the position of the carbonyl group with the lowest numbered carbon. We're also going to use the ending or suffix ONE. All right, so here we have a diagram. We have 3 carbons. So that's going to give me the prop part. I have an aldehyde, or I'm sorry, I'm saying aldehyde, but I really mean ketone, because again, this OH group, this double bonded oxygen, I'm talking too fast for myself right now, this double bonded oxygen is in the middle of a chain, which is telling me that I have a ketone. So I'm going to use the ending ONE, and then for ketones, you have to tell what carbon it is located on. So I'm going to number it from either left to right or right to left, whichever is going to put the lowest number. Because we only have 3, either direction gives you a 2 on the carbon that has that double bonded oxygen. So that 2 goes out in front. And then finally we have 3 hexanone. We're going to set up the 6 carbons. I'm then going through the ONE is telling me I have a ketone, which means I need a double bonded oxygen on my 3rd carbon. Okay, so I've counted from the left 1, 2, 3, put my double bonded oxygen, and then simply I'm going to fill in the rest of the hydrogens properly around the carbons. And you'll see that this carbon already has 4, so 1, 2, 3, 4, so it doesn't need any hydrogens. All right, so I know that was a lot of information, but we're going to practice these different groups tomorrow, and you should be all set to go.